Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. Today, we have some controversial news that we'll get through right at the top of the episode, or some things that made the rounds. But we also have a couple of interesting web topics with SAML and external entity injection. So we'll start off with our somewhat controversial topic, and this was the ESP32 backdoor news that was circulating. I'm sure some of you saw this. One of those things where the marketing department of this company had kind of went on and said, "Oh yeah, we found this backdoor," and then the media picks it up and circulates it around, and thousands of these ESP32 based devices have a backdoor in them, and ESP32 is attached to China, so there's some of the political aspect to it, and it just kind of kept spiraling out of control.
Yeah, and
Um,
I didn't look into the original presentation, but as I understand it, or at least commentary I have seen kind of in the follow-up to this, is that like the presentation itself didn't present this as like this is some crazy backdoor from China. That
it
tended
did
to
not.
be, yeah, okay. Like the researchers were more responsible here, but once marketing got a hold of this idea, they ran with the most clickbaity version of it, it
That's
seems
that's pretty much
like.
exactly what happened. So when it was first talked about, I had taken a look at the slides. They weren't super easy to get through just because they were in a different language and I had to kind of try to translate them and stuff. But yeah, they didn't call it a backdoor. They had just kind of called out the fact that, hey, there's this hidden API and you can do some useful things with it. Very like fair to call out. And I think it was literally like one slide. Like it wasn't even what the whole presentation was centered around. But then, yeah, like the marketing department of that company in their like blog post or whatever had called it a backdoor, and that's kind of where that got picked up. Now, one of the things that I had talked about initially, and so I'd seen this before we went live last week, but I wanted a little bit more information before we talked about it because at that point it was just kind of the slide and like the news was just starting to come out. There wasn't really a lot about it, so I didn't want to make any hasty judgments. But at first, I was kind of thinking it might be one of those cases where the way a lot of people use backdoor and the way researchers use backdoor sometimes isn't always aligned, because I have definitely heard researchers, and I think I myself have referred to a backdoor in the past as just like, hey, there's this debugging functionality that's there. It's not even necessarily very accessible. You might need like a password or an encryption key or something to get at it, but there is like this debugging backdoor that can have some powerful functionality. Whereas when a lot of people talk about backdoor, they're talking about like, you know, kind of evil mustache twirling villain style where it's like, yeah, we put this functionality in all these devices so that we can spy on people and and like grab the information. And like I think it is worth calling out that there is those different uses of the term, and even like where the marketing department was kind of involved there, like maybe that wasn't what happened here, but I think you do want to give the benefit of the doubt to researchers sometimes with how they use backdoor, because you can be a bit more charitable with how you interpret it.
Yeah, I think there's kind of the side of backdoor being just an alternative access method, which
Yeah.
generally isn't a good thing. But and it kind of gets called out by Zenokova in his post, the ESP32 backdoor that wasn't, where he's kind of talking about the definition of it and being typically a covert method of bypassing authentication and the sense of there being like intentional malice in what's being done. Whereas the way it sometimes gets used in a more secure context or security context is more just talking about alternatives to like the normal flow, but not necessarily malicious. And perhaps that's just a bad term to use for it. But
But it
kind of
is one
using
that's
front door,
used.
back door concepts rather than
Exactly.
malicious backdoor, I guess.
Yeah, and like you said, Neokova kind of calls out that intentional malice aspect, but I think that does kind of ignore the fact that there is, like I said, the other use for it. So yeah, let's get into the post a bit here. So the backdoor that was called out was essentially these HCI or controller interface commands that could be used to read and write to the controller's memory. Um, as you would expect, these are like debugging functionalities. It's things to help debug. But what's important context there is the fact that you're not going to be able to remotely access these commands at all or anything. And if you have the ability to run these commands on the device, you already have the ability to probe memory. Like you have the ability to read and write. So it's not really a privilege escalation in that sense. And yeah, as Z had brought up here, Espressif had also put out a post after the fact about this, and they had kind of cleared that up as well. But yeah, Neokova goes a bit into like their claim here and some background, because I was a little bit surprised by this actually. But with his Apple background, because he had worked at Apple for some years until like a couple years ago, um, they had kind of looked into a lot of this because of the fact that Apple uses Broadcom chips, and they have kind of, similar stuff going on here. It's a pretty common vendor functionality. So yeah, ultimately it came down to some FUD being spread by the press release from the marketing department, but it's a little unfortunate because the researchers, it seems like, didn't have any intent of doing that. So they might have got tarred with the same brush of people that were upset about this being circulated as a backdoor. That said, even though it isn't a backdoor and it's not something that can be used remotely, it seems there was a bit of concern taken even by Espressif here. And you had mentioned before we went live with the show that they have actually taken some steps to remove this functionality and be more transparent about some of their command sets in the future.
Yeah, and I think that's actually a really nice step to see from them. Obviously, in recent times, there's a lot of concern over what China can do, giving them more consideration as an adversary in the tech world. And that's been ongoing for the last several years. Like the big thing that kind of comes to mind for me was kind of the banning of I think it was Huawei devices in like a lot of governments, both Europe and the US. Kind of ban
Yeah, I
just Huawei
remember.
devices in mobile communication.
Yeah, I remember a big thing was the towers, like the cell towers for Huawei as well. That was a concern around the time. But yeah, that was kind of the catalyst for a lot of that
Yeah, and I mean, more
conversation.
recently, you've got stuff like the TikTok ban and data going to China with that, or being able to influence or whatever. And then you've got kind of this, and it's all kind of tying into Chinese company gets some foothold. What might this mean? And so the steps that they're taking here, Espresso, one, as you just said, they're going to have the patch. And I think it's kind of cool that they're saying they will document vendor specific HCI commands going forward, to have that actual transparency. And that's a really nice step, because then you could also say, like, you have a bit more insight, I guess, into, is this something that is like meant to be hidden, or is this just something that exists because somebody wanted it? And to be fair, like, you can also just hide in plain sight when it comes to like a malicious backdoor. Like, that does kind of exist too. But I think it is a positive step to simply document it and kind of having it there, so it's not like, oh, this is some secret functionality. It's like, nope, this is what's it there, has a purpose. And that way you could also just make a better decision for your own threat model, what matters or what doesn't matter, which is also an aspect that the Dark Mentor post kind of talks about. It's like, whether or not this is a vulnerability depends on your threat model. They call it like Tesla having one of the Tesla attacks, basically. In that case, it was able to get around their sandboxing because of the compromised user on host, whereas a lot of consumer devices, this level of access basically means you're the device owner, and there isn't really a trust boundary being bypassed. So, it gives enough information that you can start making that decision for yourself if you're going to use some of these devices.
Yeah, I think people struggle a lot with the like hidden versus secret aspect, where it's like it's just undocumented functionality that they don't think end users need to know about or should use, so they just don't document it. It's not that it's, some major secret that they're using maliciously. And I guess a bit of a like self shout out or whatever, but this situation sort of reminds me of the conversation around the PSP in AMD chips. So that's the platform security processor, which we've published some blog posts on in the past on reversing that. But the PSP also has a debugging, like a whole debugging framework that's set up that can allow you to read and write into the PSP memory. And once you have access to the PSP, you can do a lot. because it has like direct access to the memory controller. It's the root of trust, so it can talk to everything. And because of that, it is very like, if a adversary had control over that, they could do a lot, and you would not be able to even really know or have a lot of control over what they can do, because it is the most privileged component in the chip. The thing is that debugging functionality has a lot of gateways to be able to actually use it. For one thing, you need like, a private key, and you need like the private key to be able to even communicate with it. And even if you have that, on consumer chips, it's not even enabled. The fuse for enabling the debug functionality is blown, so you like that functionality isn't even enabled on most chips. But despite all of that, a lot of people will say, oh, this PSP thing, it's pretty suspicious that it's encrypted, and there's it's this functionality that the vendor won't document. It's all NDA'd. What are they up to? Whereas, like, if you actually reverse it and look into the code, like, you can see pretty clear evidence that that's not what's going on. And AMD has actually kind of taken some steps towards the same direction as Espressif has done here. They have the Open SIL initiative, where slowly over time, some of the PSP code and whatnot is being open sourced, and like there's like the core boot integration and all that stuff, so they're sort of moving slowly towards more of a transparent stance too. So yeah, I mean, I sort of understand some of the concerns, especially with China. They do have some weird laws with the fact that if you're like a company that's established in China, if the government wants some information, by law the companies have to hand it over. And I think it's good to have some healthy level of skepticism with that and keep that in mind. But I think a lot of the time it does go too far, and that is kind of what happened in this case, I think. When
Yeah,
you have like these ESP32 devices and these commands can't be accessed remotely and everything, like, it's just not a realistic threat model to worry about, I don't think.
yeah, at least not a realistic threat model for most people to worry about, like at the consumer level. And there's also just the aspect that and there are differences in nuance here, but yeah, China has kind of their laws when it comes to certain control by the government. But then we've also seen that the US has like their own kind of secret courts for getting access to certain things too without needing to go through the normal like like the normal like subpoena information or whatever, and like
Yeah, the
kind of
FISA
public
courts and
process.
stuff. Yeah.
Yeah, like there's been that process, and I'll be honest, I don't have a lot of details on how that works, so I'm not going to say like, and it is exactly equivalent to like the Chinese, because I think there are differences in nuance there. But it does seem like, generally speaking, if a company is operating in a country, they have to obey the laws there, and the government has a lot of power no matter what country you're talking about. But yeah, I don't want to necessarily draw them as being equals, but it does seem like countries with a lot of power are able to use that power. And it just kind of comes
Yeah.
down to whether or not where the trust lies and kind of which side of the aisle you stand on, I guess.
Yeah. Yeah. 100%. So yeah, this is again just kind of one of those stories where marketing department ran amok, but it is a little bit interesting getting into some of the nuances there. And like I said, I was fairly charitable towards the research team in general from the beginning. But yeah, it's sort of nice seeing the response from Espressif, like you said, and seeing how they're going to try to counter like that narrative in the future by being more transparent. That is a good thing. So some positives did come out of the story.
Yeah.
All right, so another somewhat discussion-focused topic, but Zetier had put out a very interesting blog post on speedrunners are vulnerability researchers. They just don't know it yet. And as the title kind of gets into, it's comparing the field of cybersecurity research and vuln research in particular with a lot of the stuff that goes on in the speedrunning community. And this is something I've kind of thought about before. We might have talked about it on the podcast because I know you, Z, you have a particular interest in some of the speedrunning content. And I think like you've looked into it with like Mario and stuff, right?
Yeah, like I had like a RNG manipulation on one game, like Mario 60, or no, Paper Mario. race thing. Like, so I've looked into it a bit. It's more adjacent to some of the work I've done when it comes to games, but it's been around for me. And just like tasks in general, actually, some of that's getting I mean, it is technically speed runs, but there are some fun things that can be done when you have the vulnerabilities in the games that aren't necessarily speed run. They're just cool.
Yeah. And that's kind of what this is getting into, is like the tool assisted speed runs and taking advantage of like glitches and bugs that are in the game in order to shortcut and, get a faster time. Because especially with these really old games where you're talking like, 30, 40 years ago or whatever, speedrunning via conventional means and not taking advantage of issues is kind of already capped out. It's hard to really optimize your run much more than it has already been done until you start getting into taking advantage of these flaws in the game. And while it's not like the speedrunning community isn't something I can claim to be a part of, it's not something I've really like looked into a ton or even tried to speedrun a game. I have always found it sort of fascinating from the outside, and seeing the length that some people will go to try to speedrun, like they say here, like looking at the code, reverse engineering the game, and trying to find like these glitches and stuff. Like it is really cool to see the dedication that people have into speedrunning. And a lot of it does have overlap with what you see in, vuln research and exploit development. And that's kind of what this post is calling into here, is just saying like, there's a whole industry that's built that also leverages these things with vuln research. And if you're someone that's interested in game hacking and kind of has been doing a lot of that already, then maybe vuln research is something that you would be interested in doing too. And ultimately it's a bit of a hiring post. Like they're saying, hey, if you're interested, hit us up and
Yeah,
we'll see if you might want to work in this industry.
I find the fact that they're going the hiring route, like use this for hiring, to be really interesting. So this is a company, Zedier. If you take a look at the types of jobs they're hiring for, like this is, CNO development, so like maldev. This is all clearance work, U.S. government clearance work required an active clearance. It's Let me just pull up like current opportunities here. I believe they have like an Android security engineer being open and like vuln research jobs. So fairly, what I would consider serious vuln research and like maldev type work. That is, while there is absolutely a pipeline between game hacking and reverse engineering fields like malware, reverse engineering and analysis, there's definitely a pipeline there, and into the security jobs like pen testing, red teaming. Like there's a pipeline there, but I'm not sure I would say that like if you're doing the speedrun type hacks, you're necessarily ready to then jump into like Android vuln research, for example. One of the things they kind of call out here is the proof of concepts. It's like perhaps more impressively, they'll productize their exploits. Unlike a lot in the cybersecurity industry, some vuln researchers will develop a proof of concept but never actually develop the technical chops on how that exploit would need to be developed. I don't think it's a fair comparison, just because like when you talk about say an N64 bug or Super Nintendo where they'll get code execution, yeah, back in the day when we could just write shell code, people would also take that beyond just the proof of concept too. But today, like exploit development is somewhat of its own field. Like a modern exploit development, yes, a lot of vuln researchers can do it, but it is also its own skill set that needs to be developed on its own. And there's nothing saying that somebody doing the sort of game research couldn't then learn that. I think it shows I think doing it shows an aptitude for sure, like 100%. I wouldn't say that. I don't know. It just kind of rubs me the wrong way when they say, well, vuln researchers are just doing a proof of concept today, because like the dynamics are very different here. But nonetheless, like there is a very real pipeline, and it's also maybe worth noting not most speedrunners are actually doing the glitch hunting aspect of this.
Yeah, I
Like,
know like a lot of leaderboard sites and stuff will have different categories where it's like, using tool assisted or completely manual, or they'll have that kind of split up.
Well, so it's not even that. So yeah, on speedrun boards you'll not just have tool assisted versus manual, but you'll also have glitch versus glitchless.
Yeah.
Um so like in some cases you can't even use these sorts of things. But even with that in mind, it's still like even the speedrunners who necessarily do the glitch runs, they're not necessarily the same people that are hunting for those glitch runs. Like there is a difference between speedrunner and the actual people trying to build or find those glitches. Some speedrunners will do it, most though will build off of what other people have already done or seen. Because that is one of the nice things actually in the speedrun community is it's very open. There isn't a lot of trying to gatekeep your secrets of like how the exploit works, how vulnerability works. Ultimately, because any speedrun needs to have that visible, like people need to see you doing it, so it can be reverse engineered from that at the very least. So there tends to be a lot more collaboration in figuring things out. So you'll have I've mentioned before that there's a channel I like, Carl Jobs. I have no idea if I'm saying his last name correctly, but he'll do like history of certain speedruns and he'll document like X person discovered this glitch and then these people started actually trying to pull it off, and like it's a different group that's finding the technical issues versus necessarily pulling them off in an actual speedrun. Um, but that is kind of a minor difference. What they're more talking about here are the people that are doing the glitch hunting. And there absolutely is an overlap. Like my own history, back when I was a teenager, I used to like spend most of my days in I played this game Metal Gear Online. I'd spend like most of my day after school sitting in a room, we'd call it glitch testing, and just me and some people I met on that game, we'd just join in there and be trying random things until we had a bug, and it's like, what can we do with this and figure things out? And it is very reminiscent to a lot of the manual testing that would be done on a more security front. So like I said, the pipeline definitely exists. I think it's cool that they're calling it out, but I would be really interested in what level they're actually hiring anybody that is coming from that field, because it does feel like there's a gap between doing that work, especially when you're dealing with like the older games, older consoles, and like modern Android, iOS vuln research. Like there's a gap between those two things.
Yeah, games like Super Mario World aren't exactly hardened targets compared to mobile especially, where you have like layers of mitigation. You have a lot of sandboxing. A lot of these games were developed in a time when security wasn't even its own industry, or
It would
at
be
least was
cool
very immature.
if they offered like on the job training, like they were taking people that were doing this work, showed the aptitude for it. Because like I said, I think the aptitude's there, and a lot of the gap is knowledge based. It's
And you have the same
knowing,
mindset. Yeah.
yeah, yeah, the mindset too. So it would be cool if they had like those more entry level jobs. And when I looked their job listings, I didn't see that. I saw them just like mid and senior level work. But if they had more of that, like, we'll hire a junior, we'll hire somebody that's like doing this work, that would be really cool. And I think like there aren't a lot of companies that do a ton of that on the job training. I think Interrupt Labs, they'll hire kind of junior, and then some of the classic contractors, a Battelle. Names are escaping me.
Yeah, I mean, to be fair, it's not really too common because of the business model of like the VR industry, right?
Yeah, they don't
Um,
want to spend a lot of money training you. But I think that would be cool if they were offering that, especially out of this post. But I'd be curious if anybody actually goes from, oh yeah, I do glitch hunting, to actually getting hired. We'll probably never know if that happens, given that is a bit more secretive work. But
fun to
that
think
would be
about
an
though.
interesting stat to hear in a follow up from the company.
Something I want to jump back on a little bit that you had mentioned that I hadn't really thought about is that collaborative nature. And that is a huge gap when you move from something like game console hacking or game hacking into mobile research, especially, is because there's so much money in mobile VR. You don't have that level of collaboration. You don't even have like public insight very much into what the modern landscape looks like, because stuff that's posted publicly for mobile uh exploitation, it's hard to really know for sure, because it's impossible. But generally the common sentiment from people who have presented about this and everything, is that the public is sort of at least a year to a couple years behind on what the meta is in like the cutting edge mobile research field. And that can be extremely jarring coming from an area where there is that openness, there's that collaboration, you have people posting write-ups and a lot of things to refer to. That is a big challenge going into some of this like government contract work, is because of that secret nature, like secrecy nature and everything. It can be hard to make that transition, so it is worth calling out, and something I hadn't thought about when I first read this post. But it's a big point.
Yeah, like I said, a big gap that exists is going to be purely knowledge. If you've got the mindset, you've got like the practice and like figuring out kind of the rough ideas, it's just learning. Like they call out fuzzing as one of the things where, they might somebody doing the glitch hunting might like try and pull out a bit of code and just like manually fuzz it with some C versus using like AFL or something to figure that out. And that's just a knowledge gap. That's just you need to be aware of the tools that are already available, what's going on versus like a skill issue. And just since I touched on it with companies that do kind of hire on the junior side, these are all US, are mostly all US clearance work, but Interclips, Raytheon, John Hopkins, Applied Physics Lab, and Battelle are kind of the companies I've got noted as doing kind of junior positions or intern type positions that'll do some training. Like I said, they are all, I believe, clearance.
Which makes it hard to get those positions if you do not live and are not like a US citizen.
Yeah, and I think Interrupt Labs, well, I have a big list of like companies I've kind of kept track of. I don't have them noted as actually having the internship, but I was pretty sure they did, and that one was UK.
Yeah.
But yeah, I figured I'd shout that out because those jobs aren't very common, and I have spent a little bit of time trying to keep track of them for myself. So
Catalog them a bit. Yeah.
yeah, so I figured I'd at least shout it out for those of you interested.
Mm-hmm. But yeah, like I said at the beginning, I've kind of thought about that connection before, and there is a lot of overlap in the mindset, and it's interesting seeing a VR focused company making an article, like posting an article that is around that premise. I don't think I've really seen companies in that space publicly make that connection like that before, so it's cool.
Yeah, like the connection, it's definitely recognized to exist. Like I mentioned, the guy who does TaskBot, I believe he works for Bishop Fox, which is another company that does some of the clearance work, although they just do like pen testing, normal consulting too. I don't know where the guy who works on TaskBot actually fits in the company or anything. I'm not even sure if he's still there, to be honest. But like the connection's been recognized. This is the first time I'm seeing a hiring attempt out of it, though.
Yeah. All right, so I think we can move into some of our vulnerabilities of the episode. And our first one is from GitHub Security Lab, and it's on bypassing SAML SSO auth with parser differentials. And it has to do with Ruby SAML and its XML parsing, and a pretty interesting logic bug that can lead to a fairly impactful bypass. I'll let Z get into the details.
Yeah, and kind of the core issue comes down to the fact they end up using two different parsers to pull out the information they want to go with. So if you're not familiar with SAML, the high level is it was like OAuth before OAuth. It was used for single sign-on. It's XML-based, and you kind of pass the data from the identity provider is going to pass this data back, and it's going to pass back an assertion that includes information like who this user is. It might include their roles or permissions or whatever. It can include like any sort of information. And then it'll also have that it'll have that information signed by like the identity provider's public key, so it can't be tampered with. And in that signature, they'll sign a hash of the assertions. So you kind of have two things that need to be validated there. You need to validate the signature, and then you need to validate that the actual hash of the assertions matches what's there. So the problem is when they're pulling out some of that information, they use REXML. And then when they're pulling out other pieces of information, they end up using this Nokogiri. So you have these two different parsers going on. They end up, if you can make them see different information, you can end up having a bit of a vulnerability. So they kind of walk through exactly as they jump through the code, like this piece of code pulls this does this. I'm just going to jump towards the end here in this last image. Let me pull this up so it's larger for us. This image kind of shows the core issue, where they end up having two signature blocks included in here. And one of them will be read by RE XML, and the other one gets read by Nokogiri. And inside of each of those, there is the normal signature value, which is the public key signature, or like made with public key, and the digest value, which is supposed to sign. You'll see there's a reference in the field above it that points to what it's supposed to be signed. So this one, test ID, signs this assertion, test ID. This one, because it never actually gets used, doesn't actually point to anything. But either way, what ends up happening is when they're going to validate the signature, so first step is you validate the signature. As long as those match, then you look the digest that's inside the signature and make sure that matches. So when they're doing the signature, first they're going to end up asking REXML or Nokogiri to pull out the signature. But then when they're getting the signature value, so REXML pulls out this block, or I'm sorry, I'm probably going to keep mixing these things up. Nokogiri pulls out this signature block. It's the first one that it sees, just kind of reads through, finds the first one, sees this signature block, and pulls it out. It's like, here's a signature. But then when they ask for the signature value, they parse that out using REXML, and REXML is going to look inside of the assertion. It's not going to see it inside of the status block. It's like, that's not the right place. I need to go here for it. And so it grabs,
second block. Just for those listening.
It sees a signature that is part of a separate signature. Now, on its own, this isn't actually much of an issue, because like the signature, you still need to provide a valid signature value for what's up here, which means like this signature value still needs to be correct for the signature that's there. It's like, on its own, this isn't necessarily a big issue. You're saying like, yeah, it's reading the value from the wrong place, so that's very weird, but it needs to be the right value. So, it's not much of an issue. But then the next issue comes when it's trying to pull out the assertion. It looks for the assertion tag, and then, it grabs so first they'll look for that assertion tag. So Nokogiri will pull that out, and then it looks for the digest value, which again, kind of like the signature value, is getting pulled out by REXML. So it's going to pull out a digest value, and this kind of where the key problem happens. REXML isn't looking in that original signature block for that digest value. It's looking in this other signature that it had. So it will pull out a different digest value that wasn't part of the actual signed data.
It's not actually a validated digest. It can be completely attacker controlled.
Yeah, basically, they're validating a signature. The signature value needs to be valid for that signature. It's so confusing because we're talking about signatures and then the signature. Yeah, the signature of the signature needs to be the signature for the signature. Hopefully that's clear to everybody. But yeah,
this is going to be one of those ones where we're trying our best for people who are just listening, but looking at the video feed, if you can, would be very helpful to see the diagram, because it's really hard to go through audibly.
Yeah, actually, I made an image for you when we were talking about this. I'm just going to pull that up because I feel like I am biased in this. I feel like I did a good job with that image.
I think it did kind of enhance what the problem is, because when I first did a read through of this blog post, I was a little bit confused on why the security implications matter, because like Z said, you have that issue where you have the two different signature blocks, you have the value being pulled from the other one, like the second one instead of the first one. And I was like, okay, I understand that. What I don't fully understand is why that matters for the SAML bypass. And Z had kind of annotated this diagram with a few more notes about the digest value specifically, and that kind of helped me understand it a bit. So that's the image that he's pulling up here now for those who can see it.
Yeah, knowingly, since I shared that on Discord, I can't include this as a link, so you're just going to have to trust what's here.
Well, we can just pull it out into I can make a screenshot of it with Imgur or something.
Yeah, we can do that later.
Yeah.
Anyway, this is generally the situation you end up in. You have the signature that is highlighting green. It's that top block. that the digest value in that doesn't get used, and the signature value of that doesn't get used. Instead, of use this other signature value. But again, that signature value does need to be correct. So like it is validating that signature, but then when it gets a digest value to validate the assertion, that is where that is extracted completely independently of the signature. It doesn't need to be valid or validated. It doesn't need to be signed. Therefore, you can have that assertion contain whatever information you want. Because the digest is used and it's not signed. It is not protected. So that just means you can have an assertion say whatever you'd like it to say. You can tell it you're a completely different user, you have different privileges, whatever. You control the assertion, and if you control the assertion, you control, like, it's God mode when it comes to SAML.
That's a good way of putting it. So yeah, the impact there is pretty large, and the issue itself is very interesting in how it happens. And it's one of those issues where it's hard to imagine it being easy to spot in pure code review. You would have to look at the system as a whole and kind of look at.
Well, I believe they actually did catch us with code review. Like, that was something that they said the first thing they queued up on.
Yeah, I'm not saying it's impossible to find with code review, but you can imagine how it would be missed. Especially, like, that's generally true when we talk about these differential issues, because of the fact that you have to look at what the consequences would be of any differentials. But especially with how complicated the consequences of the differential are here, it kind of adds another layer of complexity there, is what I'm getting at.
What I would say, though, is, like, I feel like when you see these differentials, like, yeah, years ago, there wasn't as much of a consciousness about it, but coming at today, like, seeing different parsers being used should automatically be a red flag for, like, why are they doing this? Why are they using multiple parsers? Especially when this isn't like, parsing the URL and then passing it to another program where you kind of need, like, there's no way around it. This is a case where they're parsing it in the same language using different parsers. And
the
it
same
has
function even. Yeah.
Yeah. And the reason for that has to do with the functionality that may or may not have existed at the time for, like, the different libraries. So they had to kind of switch between which one gave them whatever piece of functionality they needed. But yeah, like, I feel like if you're doing code review, that should just be a cue, at least, to look into these parser differentials. At the time this was written, maybe that wasn't, I don't know when it was written, maybe that wasn't kind of in the general consciousness to look at, but it's definitely something you should be aware of today and should be a red flag. At least, in my opinion, it's something that, should be a red flag on code review.
Yeah, that's fair. I kind of said that it could be easily missed, but I guess what I should have said is that the consequences of it could have been missed, and, like, the impact could have been misevaluated. But yeah, seeing two different parsers being used on the same input within the same function is pretty suspicious. So that's a fair call out. But yeah, I mean, not much more to this post. Like you said, once you exploit that issue and you have control over the assertion, it kind of gives you God mode, and that's the end of the line. There's not much more to go there. But yeah,
it does seem like they were able to exploit this in multiple ways too. Like, because it seems like there's a overlap here with a hacker one and the author of the post, both kind of noticing this and trying to come up with an attack for it, and taking different routes. So there are probably other ways of going about this too, like just other structures, I guess, that would lead to it. But I mean, that's kind of not necessarily a given when it comes to parser differentials, but it's not that uncommon that you can have different differentials.
Yeah. And continuing the theme of trouble with XML, we have a post on external entity injection in PHP through load XML. This was posted on PT Swarm. And yeah, so XML entity injection isn't something we talk about too much these days. It's sort of, I think it's sort of seen as a dead attack in a lot of senses because of, like, default configurations. It's not really hittable. But if you have some code that specifies some attributes that allows external entities, then you can get some interesting problems here. And Z, I know you found this one interesting. I'll let you get into it.
Yeah, and I won't say it's dead. It's just, when it comes to, it's kind of for a similar reason we don't talk a lot about XSS. A lot of the cases of it are just, you had a flow of user controlled data into a vulnerable sync that was being loaded like vulnerably or whatever. Like, it's not that interesting. It's not that deep.
There's not much to the attack generally. Yeah.
Yeah. In this case, though, there definitely is more to the attack, and it pulls out one attack method that I was actually really excited to see them do. Because the first time I saw it, I'm like, it was with the CTF. I'm like, this is cool. I'd love to see this actually happen in the wild. So let me kind of dive into it a little bit. And I will be honest here as I'm going through this, I am going to be a little bit fuzzy on some of the details because, quite frankly, I didn't follow them in this article. I have a few questions about this, so I'm kind of just taking the author at their word on some of this and getting to the point that I did find interesting. So yeah, you might want to give this a full read through yourself to get a better picture of it. Kind of want to have that preface there because usually I have a good handle on these bugs as we're explaining them. This is one where I didn't follow the entirety of this post and definitely had some questions. But it starts off by laying out just their case here. And while they're kind of using a somewhat, possibly fake code, I'm not sure if they've actually pulled this out there. They did actually have this with two CVs in simple SAML PHP and in a unnamed vendor. So we're able to exploit or using this attack. We're able to pull it off in like a real situation. Just we don't necessarily know the vendor apart from the simple SAML case. So they start off by just laying out what are some of their challenges. First of all, it starts off just by doing a load XML on the user input. So creates a new document, doc load XML, user input. Saves that same document and then loads the document again. Purpose of that, I believe, is just basically because external entities will be stripped when you initially load it if it's not enabled, and it's not enabled by default. So it's basically using that as an option to strip the entities out of document, doing like that double load of it. That is a little bit weird. When they do the second load of it, they end up using DTD load and the no net flag, which both kind of create their own challenges there. They comment that DTD load ultimately allows external entities to be loaded, but does not allow one entity to be inserted into another. I tried looking into that, and that's one of the things I'm a little bit confused about. I'd probably just want to play with it and actually see that happening for how that works, because that isn't like a documented side effect of using it. The document or the PHP documentation is just it loads the external document type. Like, it doesn't say anything about this other side effect of it, like allowing them to be loaded. So I believe what's going on there is just it allows it to be loaded inside of the other document, but you can't actually insert any of the things that it generates. The conclusion here, though, is that you can't do the usual thing of like read a file and then put it into a call to your attacking website to get exfiltration of that data. No net is just saying can't use HTTP, can't like send it out on the over the internet. And then there's also this fact that it checks for the note type of all the child notes be. If it's a XML document type, it's like, oh, we don't want this to be the case, so we're just going to die on that. So what their attack actually comes down to, kind of go into their bypass. So the doc type issue, this last one I just mentioned, where it's checking, basically they don't bypass it, or they fail
They don't
on
really
it
bypass it, but it just doesn't really matter.
Yeah,
because of the ordering.
Yeah, they fail on it every time. But what they depend on is just getting their entities loaded during the initial loads and not actually being needed during the processing here. And they do that by using parameter entities. So basically get around that using their parameter entities. Those are the ones that start just with like %name. And those will be processed on loading rather than on the later read of it. So they're able to get it through there and get some things in, just not the usual attack method. Then they get into no net. No net is basically not very effective on PHP because you have PHP :/ filter, where you can do a lot of stuff that isn't over the network, but you can still cause like a DNS request to happen or something of that nature. So you've still got the issues there. But one of the big things, the part that I found interesting is, they've bypassed, they're getting some of those entities loaded, I talked about. but how do they exfil the data? Because, they can't inject those entities into another entity and all of that. They still have that sort of challenge. And that's where they talk about a couple of things that could be done, but they lead into Lightyear. And I hadn't heard about this, but when I looked into it, it's actually based on something we talked about on episode 243. On episode 243, we didn't. So this was a topic that we had on the podcast and then ended up dropping it from the episode because it is purely a CTF related post. But I thought it was a cool attack, but it's also very CTF, very deep in terms of how this works. So I'm going to include the link here. It's PHP filter chains file read from error-based Oracle. And on episode 243, this post made it as one of the Portswigger's top web hacking things of 2023. And during that, I kind of spent some time talking about it because I did find this to be a really cool thing. Just because it was CTF, we don't tend to cover the CTF bugs. We want to see it used in the wild. This is the first time I'm actually seeing it used in the wild. I wasn't aware of this Lightyear attack, but it's based on kind of improving this error-based Oracle idea. So the idea of this error-based Oracle is kind of creating a resource exhaustion based on whatever character you're trying to read. So you can get a yes or no question being asked of the server by getting it, like, if it's this character, it's basically going to expand out massively to the point where you're going to hit size limits in PHP and you'll just get an error. So you get that error, or if it doesn't match, then it won't expand out. So you can kind of ask yes or no questions of every character in order to dump a file byte by byte, basically. The post goes into the details on that, but it was this really cool way of dumping information using the error. Lightyear's expanding on that. Let me pull up the Lightyear post. It is expanding on that, making it a bit more efficient, a bit more useful, and putting out a tool to, as they say, it goes further, faster, with less, in more practical terms. Lightyear can dump tens of thousands of bytes using small payloads, being a few thousand characters. So it's an improvement on that, which again, I'm not going to dive into here, but I do want to call it out as something worth taking a look at. And that's where this attack went, is they basically use this Lightyear attack in order to use an error-based Oracle to be able to ask like yes or no, or dump part of the data out. But I mentioned before how they have that check on the document type. And in their attack, no matter what, they're going to fail this check, which means they're going to get an error every single time they run. And they don't have a way of distinguishing between this error, this runtime exception being thrown in, and an error coming from the error-based Oracle. And that's kind of neat. Like, if you want to use an error-based Oracle, you need to be able to determine that the error was triggered from the Oracle. Otherwise, it's not really telling you anything.
Yeah, you have too much noise. Yeah.
Well, you have, in a sense, you have like either no signal or no noise. Like, it's all the same.
Yeah.
So yeah, the issue with using Lightyear just on its own is they can't distinguish those errors. They call that out as it's impossible to distinguish one HTTP 500 error from another. So they kind of start digging into, well, what are the problems with like their conventional payload? One of those issues is like using the GET request. They're putting an entity in there, so they are using the parameter entity, so that gets kind of dealt with earlier, so that's not really the issue. But the payloads here are going to be very big, very large files that they want to be able to dump. So they did have a few things like make sure they're not passing in any illegal characters and all of that into a URL. Part of that's done using another attack or technique called wrap. And I believe this is also something that comes out of at least in part, the other post about PHP filter chains, because I vaguely remember them needing to add a prefix onto it. But yeah, this is basically using PHP filters to add a prefix and suffix onto it. They need it to be in quotes for this particular attack. They need to be able to strip invalid characters, things like that. So they end up using Lightyear, and then they end up using wrap as yet another tool. One of the other challenges they wanted to tackle here was, what if they're in a situation which is true no-net, as they call it, when outbound TCP connections are actually being filtered. So in those cases, they need to use a local DTD file, a document type file, and they were able to solve that using just a data protocol and kind of passing it all in there. But then you're getting an even larger payload needing to be passed around because you've got all those PHP filters, and now that needs to be part of this data URL. So they end up using zlib compressions. They use the PHP filters zlib deflate, convert base64 encode. So like their base64 for illegal character stuff, zlib deflating, so they're getting it all through there using PHP filters. Just a big chain of stuff going on here in order to actually get this to work. And unfortunately, it is a big chain that is really hard for me to describe on here, but it is a really cool chain. I recommend giving it a read. You might, like I said, there are some questions I had reading this that you might need to skip over yourself, or maybe you'll just get it and I'm just being stupid. But yeah, I thought this looked really cool, and it's a real world application of what was just a CTF issue. So I really liked seeing that. I didn't know about Lightyear, so that's also something I just found out about. Big long documentation on how that aspect works too, which is nice to see. I haven't read through all of it, but scrolling through it to see the comparison with PHP filter chain, I think it also does a bit of a better job explaining some things I remember from that, along with, of course, expanding on it for going faster and all of that. So really cool research that this kind of led me into that I wasn't aware of. And yeah, it's just really cool to see this make the jump from CTF to a real world attack.
Yeah, and it gets really complicated to follow when you have these multiple wrappings and layers to a single input, and you're triggering all kinds of different side effects that are useful to you, and you have like the side channel aspects, and yeah, it gets really complex. This is probably one of the most complex attack chains I've read in like a web focused post. So it is a little bit hard to follow, but I think there is still some useful information in there if you're looking at like external entity injection and, like you said, taking advantage of sort of a technique that was out there before, but that didn't really seem to be used in practicality. So yeah,
Yeah,
very
and
cool.
I think when we were talking about it during the Portswigger like top stuff 2023, I feel like I might have even mentioned there, like, this is a really cool thing and I would love to see this used in the wild, like in a real attack. So seeing it used in a real attack is kind of exciting, even if I'm not able to explain it very well.
All right. So, getting into our next topic, we have a post by Theory on reviving the mod probe path technique for Linux kernel exploitation. So, for those unfamiliar with the mod probe path technique, we've talked about it a few times before, but it's been a while. Linux has the mod probe utility, which is used to dynamically load kernel modules when a feature is needed. And it used to do this, for example, automatically when executing a binary with execve. It'll look at the header and it'll look for the file magic. And if the magic isn't recognized, it'll try to do a lookup and load the module that it needs. And what was useful there was, if you're an attacker who has arbitrary write in the kernel, there's a variable that the kernel uses to store the path to modprobe. And it'll use that and launch that binary as root. And so if you overwrite the modprobe path variable to get it to point to a binary that you control, and you create a dummy file that has some unrecognized magic and try to get it loaded, you can ultimately get modprobe, like what it thinks is modprobe, ran as root, and use that for your privilege escalation. It was a very useful primitive until about a year ago, where that modprobe path technique was patched somewhat. And that was because the exec path that would search and request the module that would call into modprobe no longer has that code. That code was just stripped out. The thing is, though, while that execve path was the easiest and most straightforward to reach request module, it isn't the only way. And another way that's documented here by Theory is the AFALG socket family, or the algorithm interface for Netlink. With that family, when the bind syscall is invoked and the ALG bind handler is run, it'll search for the type that's given in the address struct. And if that type isn't found, it then tries to call a request module to search and load that type. And it's nice because assuming you have access to those sockets and they're enabled on the kernel build, there's no capabilities or privileges required to do this operation. And this socket family seems to be included in a lot of major distributions. So just sort of a alternate way to reach the same end goal for the mod pro path technique, getting around the fact that this was patched out in its usual way. So yeah, nothing too crazy, but it is useful to be aware of if you're doing, Linux exploitation and you want to take advantage of that technique. It's a very nice technique because it's data only. You don't need to hijack the control flow in the kernel, which comes with its own challenges. You can just, if you have that arbitrary write primitive, you can just write into this area and get root through the kernel's existing mechanisms. So yeah, useful post by Fiori here. I do kind of wonder why there wasn't a bit more effort put into mitigating mod probe path because of how popular it is. And the reason I say that is I think it should be fairly like mitigatable if you take advantage of the page tables, because to mitigate a lot of situations where it could be used, I feel like that path shouldn't need to change very much. And if it does, you could set up like a system call or something in the kernel to facilitate that. But otherwise, it should be possible to just write the path to that variable and then modify, like put it on its own page or something, and then modify that page to be read only. In which case, a typical arbitrary write primitive is going to have to do a lot more work to take advantage of that. They're going to have to go into the page tables, change the pages, reload them, all that stuff. Like, it would still be doable, but it would make it at least a little bit harder to do. So I'm a little bit surprised that there wasn't more effort put into mitigating mod probe path, but it seems like as long as you have an alternate flow into request module, you can still use it pretty well. So useful information to know.
I guess I'm just pulling up. I didn't look into this. I just pulled up the commit here, and yeah, it seems like basically they weren't necessarily treating this as we're trying to make mod pro path overwrites not work, whereas rather, this logic is left over from a old transition that, it's like basically this code no longer has a use. Like, it's not being done as a mitigation. It's just, this is legacy code. We don't need to do this anymore. That seems to be the case.
Yeah,
Basically,
it was very quick. It was easy to remove and try to mitigate. But
well, what I'm saying
it didn't
is,
require a bunch of work.
What I'm saying is that the fact that it's mitigating it wasn't the intended reason for the commit.
I don't know if I agree with that. Just because like the committer was Keys Cook, and he would be aware of the fact that exploits and stuff were taking advantage of this functionality. I think it was more that they looked and saw, hey, this functionality isn't really used and it's being abused for exploits. Let's take it out. I think there was security concern when the decision was made to strip this code out.
Keys Cook is the committer. Keys Cook was not the author.
He wasn't the author, but the fact that he merged it in and everything makes me think that there probably was some thought of the security concern here.
I don't know. He merges in so much code. I don't know if he's always thinking necessarily about, oh yeah, this is also a mitigation. I'd have to look through the actual email chain on the patch and see what was discussed, which I guess we do have the lore link here.
Okay, let's dive a bit deep on it, because yeah, I am kind of speculating on it, but maybe we don't have to.
Yeah, I'm just looking at.
I never remember how to follow these message chains on the kernel mailing list. I'm too zoomer to follow these email chains.
Yeah, at least on kernel. There are other viewers that I've seen that do make it a bit easier. But yeah, towards the bottom you have like the replies. And what does Keys Cook say? Yeah, like Keys Cook's only comment here is, and it removes a go-to applied to for next. Thanks.
Yeah, that mention of it being a go-to, I think, is a call out to the fact that it's used for exploitation. That's a go-to exploitation primitive, is how I read that. So I think it's fair to say that there was probably some security concern there, but nonetheless,
yeah, it's
is mainly just the fact it was an easy change for them to make, so it didn't they didn't, maybe there wasn't a conscious effort to specifically kill this mitigation and put a bunch of work into it. It was just kind of like a, hey, we noticed this code isn't really used anymore, and we can sort of kill some exploitation techniques maybe by doing it. So let's just do it.
Yeah,
Is kind of how I read it.
yeah, and that's kind of how I'm seeing this too. It's just it had the benefit of doing that. That wasn't the intended point of removing it, but it is something that has that benefit. But nobody really went through looking for, well, what are the alternatives? And
Yeah.
because that is the thing, there are other alternatives, and I did pull up just out of curiosity how frequently request module is used throughout the kernel. I'm trying to pull this up also on stream, but it is being a very slow loader right now.
Using Bootland
Yeah.
Elixir. Yeah, sometimes I have problems with that where it takes forever to load or sometimes
It
just
loaded
doesn't load.
it loaded instantly over on Firefox when I made the query. But now I've tried copying the link over and it's just sitting here. Anyway, while that's loading, and maybe all people will end up seeing is a green screen, basically there's 167 references. A lot of that is in drivers, various drivers end up calling into that. There are some more core things like the net filter work here and stuff. So, summon sounds. So yeah, it is being used pretty widely and would be hard to completely eliminate it.
Unless you do something like I said.
Well,
And
yeah, I was going to say,
like,
except for your case where basically you're protecting the rights of it,
yeah.
or you're trying to protect the rights of it.
Now, like I said, I think my method, while it would work for stopping code that's already written, you could get around that. You could just, if your primitive is sufficient enough, you could read write, find the page tables, make the page writable again, and then do it that way. Unless you have a hypervisor that is getting in the mix and protecting the page at that level, which would be nice and probably would be like, that's kind of what, Samsung RKP and stuff would do, is protect variables like that. But in the general Linux use case, it's not really a reasonable expectation. But still, I think you could probably put a little bit more on the kernel side if you wanted to seriously try and mitigate this technique, which it might be worth the effort to do so, honestly, with how powerful it is and how convenient it is. And it allows you to skip over dealing with a lot of potential problems with stability and everything as an exploit developer. So, yeah, I don't
Yeah,
know.
although when it comes to having read write in the kernel, like oftentimes, there's going to
There's so
be
many avenues you can go.
yeah, like that's kind of the route that Microsoft's gone, with protecting certain core piece of data, by making it or actually something Microsoft's done is they will have a read write mapping and a read only mapping. I forget what data they did that on now, but yeah, basically they would have most things would just need to use the read only mapping, and then they had a separate mapping that would have read write acts to actually modify it.
And that would be access through a certain API that was restricted. Yeah.
Yeah, I forget all the details on that. I just remember that they were doing that. And yeah, like that is the sort of thing that Microsoft does where they'll fight back against all the little techniques, whereas Linux doesn't tend to put that same focus on doing that. Like they'll try and stop things very broadly, make these broad changes, but less on let's stop, at least usually less on let's stop this very specific technique. Yeah, there are probably steps that could be done, but I mean, attacker has read write in the kernel. There's going to be a route at some point to something, probably. Or like you said, they could also go through the page tables and get something there. So like, it's not impossible to find anyhow.
But yeah, getting back to the post, it is useful to have this sort of generic other method for accessing this for exploit development. So, like I said, worth having in your toolkit if you're doing Linux exploitation.
Yeah, and they also include a link off to a post from Lau where, it also, they're able to do this in a fileless way, being the mod probe override, and then using MFD create to do a fileless technique so they don't even need the file to be on the file system in order to use mod probe overwrite, which is
Useful
just a fun
stealth
call
as a
out.
factor.
Yeah, you being fileless, so there are cases where that is useful.
Yeah. All right, so we'll get into some of our shoutouts for the episode. The first of which is by Alfie's CG and is on Trigon, developing a deterministic kernel exploit for iOS. And this is an analysis and exploitation of a bug that was involved in the operation triangulation chain, which is sort of what the Trigon name is a callback to. The bug is a kernel integer overflow in the Mac virtual memory subsystem. And as such, there is some knowledge required on the memory system in XNU, going through like the process structures and the VM maps and all that. The vulnerability is fairly straightforward, and the exploit is where a lot of the complexity comes in, which is often the case in when you're talking about Apple, like chains that are targeting Apple products. A lot of it is very specific to XNU and even involves getting into like some of the hardware registers and whatnot. So for that reason, I didn't want to go into full coverage of it. Generally on the show, we try to keep it a little bit more generic, and try to avoid some of the topics that get very specific. But
Like
this
mod
operation
ProPath.
triangulation,
That's not specific to Linux.
that's true. We do have a bit of a bias when it comes to Linux.
No,
we're self-aware of that.
I think the main thing actually, with just to clarify, a mod ProPath is, at least my main takeaway on that is more the fact, like, yes, they did have this patch that had one impact to like one attack technique, but same primitive can still be attacked in other ways. And like, obviously they were able to very quickly get around it. That's the takeaway, rather than specifically mod probe and like being able to use that primitive. You can apply that same idea to any target, like incomplete patches and all of that.
Yeah. This Trigon chain gets very complex, and like I said, it involves like looking into the hardware registers. You have a lot of mitigation layers on Apple that are unique, like page protection layer, PPL, kernel text read only region, KTRR, all the acronyms, lots of TLAs. But because of that, yeah, it makes it a little bit harder to cover, and I think we'll shout it out for people who are interested in the Apple stuff. It is a very good write-up. I would recommend giving it a read. We're just not going to get all into the technical details here because it's a fairly long chain, and like I said, a lot of it is Apple specific, but still a good read. The other shout out we have is an inside look at NSA equation group, TTPs from China's lens. So as the title states, it's a perspective that we don't very often get in nation state attacks, where a lot of the time, because of the nature of a lot of the organizations doing in the wild threat assessments and stuff are from like the West. Typically, you're seeing, China, Russia, adversaries of that nature. You're not really seeing the stuff that's coming from the US side. Because
Kaspersky will post that a bit.
yeah, you get it sometimes from Kaspersky, but it's a lot more rare. So this is sort of giving that rare perspective on how the NSA allegedly hacked China's Northwestern Polytechnical University, and goes through some of the process they used to try to attribute this attack to the NSA. Some of that comes down to things like the attack times and the fact that the attacks were launched during, like typical business hours during weekdays. I'm a little bit interested and somewhat skeptical on some of the metrics they use for the attribution. Now, I will say this isn't an area that Z or I are in. We're not experts in this area, so this very much is just kind of an idiot's perspective into it, or like a bit of an ignorant perspective into it. I could imagine, though, things like the attack time being launched, that should very easily be scriptable. And when you're talking about the intelligence industry, there is a lot of trying to throw false trails, create, red herrings. And I feel like that would be one of the first ones that would be thought of, is something like the attack time being launched, because it's very obvious if you have, like, if you're worried about logs and traces, like the time that these things are happening are, you would think, would be very obvious to the attacker as well. And so I could see that being a red herring, but like I said, I don't want to put too much on that because it's not really my area of expertise, but I do have some questions on how their attribution is done.
Yeah, and I get where you're coming from on that. Well, it's easy to like get around that. At the same time, they kind of they mention here, the attack required hands-on keyboard data analysis, and that I think is kind of an important detail where, yes, you might be able to just automate, like, say, throwing. I'm assuming, the NSA isn't necessarily using Metasploit exploits, but tossing Metasploit at something, and you might be able to set that up on a timer to be like, yeah, try and run on this server, like run these attacks at this time. But it becomes a lot harder to automate the follow-up to anything. So now you've compromised the server. You're probably not just going to like zip the entire drive and try and email that back to you or something. Like, you're going to need a bit more intelligence on what you're actually doing with that access and how you're like basically all the follow-up where you are, I imagine, going to want an actual human on the keyboard doing some of that control, in which case you do then become bound by where the people working. And that tends to, there are a lot of East Coast companies that are operating, or, well, I mean, obviously government too, but a lot of the government contractors too that are East Coast based and like, having that support at that time. I don't know, since they call out the TAO or tailored access operation specifically, I guess that is just the NSA in that time zone. Although even the NSA, like, I know most people are familiar with like the main NSA building, but I want to say they have like 3 or 4 uh places around the US. Either way, though, around the US and kind of US time zone. So I'll leave it at that. I don't know. I remember us having.
They're headquartered at Fort Meade in Virginia, but yeah, they have some other installments, I believe.
Yeah, they have a few other places. Either way, like, more my thinking is like, it makes sense that yes, you can easily automate like the initial toss of attacks and some follow up. You do kind of still need a attacker, like a human in the loop, to make some of the more intelligent decisions around what's going to happen next or once you're there. That like it could be delayed. Like, you could be like, okay, now I'm going to wait a whole day so I get to that different time zone. But that might not always be like the practical choice. I do find it interesting though, like, nothing on Memorial Day or Independence Day, whereas, you might think of, scheduling something there too. But these are people. There is the human element of all the attacks. So, and of course they don't. Part of it's also just, I feel like a lot of attribution comes down to the balance of the evidence, not necessarily like, oh, because the attack time was here, it's definitely the US. But the attack time, some of the human errors, the tools were found, I guess, prior to, or they call it here tools being found prior to Shadow Broker's leak. That allegedly some of the same tools were used from the Shadow Broker leak before that leak. Well, that was quite a long time ago, wasn't it?
Yeah, that was like 2016, wasn't it? That was a long, long time ago, I thought.
Yeah. Either way,
Shadow
so something like that.
2016.
Yeah. Something like that, like, if I'm understanding that correctly, that can, yes, sorry, they say they have suffered multiple breaches through the years, and some of the malware found there prior to the leak could be traced to Shadowbrooks. Like, that is at least a little bit more of a solid connection in my mind. Although at the same time, let's just say another APT compromised the TAO operations
before the public leak. Yeah.
Yeah, and then, planted those tools. Like, that sort of thing has happened in the past too. So, like, it could be planted in a sense. Like, there are things, but it's the balance of the evidence that leads up to an attribution. It's not like this is 100% definitely one side or the other. But yeah, neither of us are really experts in this area. Just,
yeah, as you can tell with our discussion, though, it is obviously something like that we do find very interesting, and it's very fun to talk about. So we wanted to shout it out because it has some very interesting stuff here with how they do the attribution. And like I said, it's an angle that's not really explored very much. But we're not going to go too deep into it just because we don't have a ton of the, we are like pretty much speculating here and then just having our own thoughts on it. We might circle back to this topic if we can get someone on the show who has a bit more expertise in that area. I think it is something that could be a very interesting discussion, and there's a lot of questions that would be interesting to have answered. But since we don't have anyone that can really do that at the moment, we're just leaving it as a shout out for now.
Yeah.
All right. Unless you have anything more to say, Z, we'll wrap it up there.
Nope, those are all of our shout outs.
All right. So as always, thanks goes out to everyone who tuned in, and we will see you in the next episode.